This is a robot actuator that I built. An actuator is kind of just a thing that moves stuff. They're used a lot in robots, but they're used in other things too. This one uses something relatively new called quasi-direct drive, or QDD. It's very simple. There's a electric motor and a high-efficiency gear. And this enables several things, including force feedback, which helps a lot with safety as well, and high torque output. It's used a lot in, newer robots, but could also have benefits for other stuff. So this is the one that I built. This thing, if it works, should have enough torque to, let a whole robot do a backflip or all kinds of things. It has a few features that I think could make it a very good QDD servo. It uses a very powerful motor, one of the strongest motors that you can buy right now. I use something called a planetary gear. This gives it a lot of torque and makes it very smooth. And then I house the planetary gear inside the motor to save space, make it more compact, and easier to fit into stuff. So this is a pretty unique design, and I wasn't sure if it would work or not when I first saw it. So the first thing I did was I 3D printed it, assembled it, and tested it out just to see if it would work. So the 3D printed actuator came together pretty well. It did have some challenges, specifically with the motor and the magnet ring. Kind of the hardest part with these usually is that you have this magnet ring. It has to spin exactly in the center of the motor, and if it just tilts a little bit or moves a little bit, then it'll crash. What I figured out is that I have to put these little shims in to preload the two rotor bearings, and once you do that, it kind of centers itself. That took me about 3 weeks to figure out, but once I figured that out, it was pretty much smooth sailing. So now that I've spun the 3D printed actuator to make sure that it spins, the next thing to test is to measure the torque output. This is a really good way to tell if, a QDD servo is going to work or not. This one's made of plastic, so I'm not going to push it all the way up to 300 newton meters because it would break. I'm probably only going to do maybe 15 or 20 just to prove that it's working. So you'll see it pressing up against a scale. Then I use the scale to measure the force, and then converted the force to torque. So once I was finished benchmarking the 3D printed actuator, then it was time to get it machined and 3D printed out of steel and metal and stuff, and then, assemble that and test it. So this is me assembling the Rev 1 machined one. The casing, everything's made of aluminum, and then the gears are 3D printed out of 316 stainless steel. So this is measuring the torque of the latest revision of the actuator. Found out pretty quickly this thing definitely has enough torque to break the test stand. I did get it up to about 120 Newton meters, but you are going to hear some pretty scary noises as it approaches that. And then the last thing I did was I had it lift some heavy weights, just to make sure that it can lift some weights. So pretty interesting actuator. Pretty happy with how it turned out. It would be nice to put this into a humanoid, but they are pretty expensive compared to the off-the-shelf ones for now. But yeah, pretty happy with how it turned out.